Okay, as I start this lesson today on factoring by grouping and talking about trinomials, the method factoring by grouping is used when you see four terms and you try to group two terms together and then take out the greatest common factor. What we're going to do is we're going to take these trinomials down here. I have 5 examples, and we're going to turn them into 4 terms and then use the method factoring by grouping. Here's our page number, Reimagine Time Day 19. Okay, looking at number 1, x squared plus 12x plus 27. Remember, this is a quadratic in the form ax squared plus bx plus c. In this quadratic, a is 1, b is 12, c is 27. So the first thing I need to do is to create my chart that finds factors of a times c that will give me a sum of b. A times c is 27, b is 12. Factors of 27, things that multiply to give me 27. Now notice I did not do -1 times -27 because that does give me positive 27. The reason why I did not is because I want a positive sum. So since I want a positive sum, I don't need negative factors over here. The only way to multiply to get a positive is a positive times a positive or a negative times a negative. The only way to add to get a positive when you have those two scenarios is a positive plus a positive. So that's why I did not include them here. Okay, if I add 1 and 27, I get 28. So that's not the sum I want. If I add 3 and 9, I get 12. That is the sum I want. So to use factoring by grouping, I am going to replace 12x with 3x and 9x. That's what I'm going to do. Replace 12x with 3x and 9x. X squared plus 3x plus 9x. The first term stays the same and the last term stays the same. The middle term becomes these two terms here. Next, I'm going to factor by grouping. I'm going to group the first two terms together with parentheses. I'm going to put an addition sign and group the last two terms together. So if this had been a negative sign, I would make that negative 9x and put a plus sign in the middle. Now I'm going to look for the greatest common factor among each of those binomials. So when I look at x squared plus 3x, what is their greatest common factor? That would be x. When I divide each of these by x, the answer will go inside of the parentheses. X squared divided by x is x. 3x divided by x is positive 3. Then, when I look at this pair of terms, their greatest common factor is 9. So I'll put 9 outside the parentheses, divide each of these by 9. 9x divided by 9 is x. 27 divided by 9 is 3. Now, we have a binomial. We have two terms. Let me show you. We have two terms. Terms are things that are multiplied. X times x plus 3 and 9 times x plus 3 with addition or subtraction in the middle. So two terms separated here. So this is a binomial. That binomial, do they have a common factor? Yes, both terms have x plus 3. So I'm going to factor out the greatest common factor of x plus 3. Then I'm going to take away the x plus 3, and hopefully you can see when I take away the x plus 3 or divide away the x plus 3, what's left? X plus 9. And that will go in the parentheses beside of here. And of course many of you will see, and I totally understand, that it would have been just as easy here to just go ahead and put x plus 3 and x plus 9 the way I'd showed you with the chart method. But when we do number 3, you can't do it that way. I want you to notice, and I'll point that out in just a minute, I want you to be thinking about what's the difference between these two compared to this one. So be thinking about it as we're going to do the next example. Okay, so in the next example, A is 1, B is 7, C is negative 44. I want to find factors of A times C that will give me a sum of B. A times C is negative 44, C is 7. So factors of negative 44, that means a positive times a negative. I want a sum of positive 7. So if I'm multiplying a positive and a negative, and I want a positive sum, that means that I'm going to have the larger number as a positive and the smaller number as a negative. So 44 times negative 1, 2 goes into 44, 44 times negative 2, 3 does not go into 44, not 44, whoops, apologize for that, 22 times negative 2. And then 4 goes into 44 11 times, 11 times negative 4. These are all the factors of negative 44. Now we need to find the pair of factors that will give me a sum of positive 7. And you don't have to write out those sums each time. 44 plus negative 1 is 43, so that doesn't work. 22 plus negative 2 is 20, so that doesn't work. 11 plus negative 4 is 7, so that's my pair that works. Okay, so remember what we're going to do is we're going to replace 7x with 11x and negative 4x, creating an equivalent 4-termed polynomial so that we can use factoring by grouping. It does not matter the order in which you put those two terms, the 11x and the negative 4x, just as long as you put them in place of 7x. Remember, first term stays the same, last term stays the same, the middle term becomes these two terms. Now I'm going to group the first two together using parentheses. I'm going to put an addition sign in the middle and group the last two together. Now I'm going to look for the greatest common factor in the first group. That would be x. Divide each of these by x. You may do that part mentally. X squared divided by x is x. 11x divided by x is 11. In the next group, they're both negative. So I know I'm going to take out a negative greatest common factor. However, there is a rule that says if this one is negative, even if it's just this one, then you must take out a negative GCF. Okay, so they do have a negative both in common, and they're both divisible by 4. So I'm going to take out negative 4. Negative 4x divided by negative 4 is x. Negative 44 divided by negative 4 is positive 11. Did this process of factoring by grouping work? Yes, when I look at it, this binomial shares those two, or that common factor. So I'm going to take out the common factor of x plus 11. When I take out the common factor of x plus 11, what's left? X minus 4. Now, I want to name A, B, and C from this example here and then talk about the difference. A is 2, B is negative 1, C is negative 15. Now, when I look at this, what is the difference between number 3 compared to number 2 and number 1? Hopefully you see the difference is for number 3, A is 2. For number 2 and number 1, A is 1. And I'm going to point this out in just a moment, but I'll point it out for these. Here, positive 3 and positive 9 were what went with my factors. Positive 11 and negative 4 are what went with my factors. Watch what happens with this one. When A is not 1, it's very different. Okay, so let's make our table. A times C, sum of B. A times C would be negative 30. Sum of B would be negative 1. Factors of negative 30, so that would be a negative times a positive. Their sum needs to be a negative 1, so that means the larger number is negative. Negative 30 times positive 1 does not add to give me negative 1. Negative 15 times 2 does not add to give me negative 1. That's negative 13. 3 does divide evenly into negative 30, negative 10 times. Negative 10 times 3. When I add those, I get negative 7, so I still don't have negative 1. Is 30 divisible by 4? No, it is not. Is 30 divisible by 5? Yes, it is. Negative 6 times 5 will give me 30. Negative 6 plus 5, is that negative 1? Yes, so that's the pair that works for me. Okay, again, I'm going to do the same process. I'm going to replace negative x with negative 6x and 5x. Okay, I'm going to group the first two together. Put an addition sign. Group the last two together. Take out the greatest common factor of 2x. That would be x subtract 3. Take out the greatest common factor of 5. That would be x subtract 3. Did this factoring by grouping work? Yes. These are the same. So my answer will be x subtract 3 and 2x plus 5. Now I want to point out, as I circle my answer or put a box around it, I want to point out that I have a minus 6 and a plus 5 here. I don't have a minus 6. I do have a plus 5. Could be coincidence. But I don't have a minus 6. So there is a large difference between factoring when A is not 1 and factoring when A is 1. So I just wanted to make sure that you knew that. You can't just use the chart method when A is not 1. You do have to either use the area model, which we'll talk about here in just a moment, again, or use factoring by grouping.